This is what quarantine does to your hair. Look at me. Look at me. Ugh. I bet this is also other people. I bet the barbershops are gonna have a huge amount of income when this quarantine's lifted. Anyway, I'm sorry. I had to apologize real quick. I'm like a year late to the party, but today I'm gonna be talking about the Spectre and Meltdown vulnerabilities in your computer. Yeah, I think those were patched about like a year ago, but they're still worth talking about. But okay, before I talk about those vulnerabilities, I need to first talk about speculative execution. So, speculative execution is one of the reasons why your processor runs so fast. If you ever heard of machine learning, where the computer, instead of you specifying what it needs to process, it can figure that out on its own using neural networks and such. I'm not going to get into that because the programming is incredibly complicated. Even I don't understand what's going on. Look, I tried to take an ID Tech course for machine learning. I had trouble understanding the course. What do you want from me? Anyway, so rant off. So speculative execution. This is one of the reasons why your computer runs so fast. You see, after you run a bunch of an instruction multiple times, your computer will begin to recognize that, hey, you're running this instruction multiple times, so why don't I just execute it beforehand before he asks me to? So then it starts doing that. It's actually one of the reasons why whenever you open and close a program, it gets faster and faster. I've actually noticed this phenomenon, and I can see exactly what happened. But if you were to say, if it was to process that instruction, but then you throw a different instruction, then it'll actually have to throw that instruction away into the refuse bin, so to speak. So the refuse bin. That's basically where you throw where the processor throws away the number. You know, like, that's just, you get the point. So when it comes to like computer vulnerabilities, that's usually when it comes to the software itself. Say, for instance, it's trying to exploit a security vulnerability in your Windows operating system. That's why Mac gets to use the tagline, Mac OS. It doesn't get Windows viruses, it gets Mac viruses. Okay, well, whatever, just ignore that last one. But here's the problem. What makes Meltdown and Spectre so dangerous is that, unlike other vulnerabilities which are in the software, these vulnerabilities are much closer to the actual hardware, like your CPU. So they can exploit multiple different varieties of CPU with multiple different operating systems. So with these vulnerabilities, you can create a virus or a worm or just any malware that can run on both PC and Mac. Windows and Mac. That's scary, because beforehand you'd have to actually specialize it. Now you get the point. This is scary. So here. So there are security measures in place, because if your CPU is smart enough to segment out these RAM addresses to certain programs. So let's say I don't know, the Microsoft Store tries to access something from, let's say, from Spotify. these are just arbitrary. Your processor will not allow it. However, your processor will start to read the instructed address before it checks to see if it's authorized. That's the vulnerability. Now, of course, if you're not authorized, they won't be able to access it. So here's how Meltdown works. It actually works around this this security measure by by using a bunch of different instructions to trick the computer into giving it what it wants, and the CPU doesn't even know it. So, first thing, let's say that you have a TurboTax that has your credit card number in an arbitrary random address. Let's say it's 0x12b2f8. That's just an address, whatever. So it will deny access, but not before it puts it into the CPU cache. Oh right, so CPU cache. This is the point where this is actually some sort of memory on board of the CPU that's about like a couple like 30 megabytes. It's small, but it's extremely fast, 200 times faster than your memory chips. That's about 8 gigabytes. Like, you get it. So now it's in the cache, but it will deny access. So what it'll do now is add an arbitrary number to that data in cache. And the CPU's like, okay, it's whatever, because it's, as long as they're not getting access to the actual data itself, it won't do anything. So what it will do, so let's say that arbitrary number is, say, 10,431. Let's just say that. So it'll start reading RAM addresses to 10,431 all the way up until it gets to the number in cache. Okay, it'll actually start reading RAM addresses, and keep track of the time it takes to read the data. So basically, it'll start a time after it executes the instruction. It'll start a timer to see how long it takes. Now, if when it gets to the RAM address that's equal to the number in the cache, that'll read 200 times faster than all the other ones. So the timer will be 1/200th of all the other numbers. Now, after it reads that address, after it discovers the address, it'll subtract said arbitrary number from the RAM address, and that RAM address is that credit card number. That's a lot of information to swallow, but you could probably see why this is dangerous, because I just use your credit card number as an example. This can be done with your social security number. That's identity theft. But that's Meltdown. So I guess what you could do in order to patch the vulnerability is check to see if the person's authorized first, then start reading it. Problem is that comes with slowdowns. But the Spectre vulnerability is different, but it still uses the same speculative execution that I was talking about. How Spectre works is that it repeatedly tells the CPU to read the RAM address containing the credit card number. Let's use the same one, 0x12b2f8. But this will do it over and over and over again. That way that speculative execution will kick in and begin just processing it on its own without instructions. But then the worm will throw the malware will throw a new RAM address to the CPU, and thus it'll have to throw away its pre-processed data into that refuse bin. So then the Spectre Spectre malware will go to the refuse bin and retrieve the number, because the refuse bin is insecure for some reason. So this is an easy fix. Just secure the refuse bin. Make sure that, or maybe even remove the refuse bin entirely. Just set them all to zeros. But there's a problem here. You see, these vulnerabilities are already in your computer. And if you had like a computer from 2017 like I did, I have a custom build I built in 2017, that means I actually have this vulnerability in my computer. The problem is, it's a lot more difficult to fix, because you can't just fix patch vulnerabilities in the hardware. At that point, you're getting into some quantum entanglement problems. Yeah, you wouldn't be able to fix the vulnerability without actually having the CPU in your hands. So we have to resort to software, such as installing checks to ensure that these vulnerabilities aren't being exploited at the moment. Now, Intel and AMD I think they have worked on a fix. Yeah, I think they worked on a fix. But it's also come with slowdowns, because you're directly inhibiting the speculative execution. So you get the point here. You have to sacrifice speed for security. And honestly, when it comes to me, I would be perfectly happy to make that trade-off. Like, here, Intel, AMD, take my money, I'll take the new CPU, if it means, even if it's slowdowns, as long as it means I'm more secure, I'll take it. I'm a very paranoid person because of how many vulnerabilities go around today. So, there you have it. Another reason to be afraid of the world.